All right, ladies, gentlemen, I got a group of warm-up problems right here that I want you to go ahead and try out. And so I want you to take a moment and copy down these three problems down here, 1, 2, and 3, and work those through. So pause the video, try them, then we'll go through that. Okay, let's go ahead and take a look at these. Hopefully these turned out well. First thing right here that we want to do very briefly is just review our quadrants. Anytime that we're dealing with sine inverse or arcsine, what we know is that our answer is going to end up being in either quadrant 1 or quadrant 4. That's where we should look. For cosine inverse, our answer is going to be in either quadrant 1 or quadrant what? 2. And then for tan inverse, it's going to be the same as sine inverse, quadrant 1 and quadrant 4. So, keeping that in mind, let's go ahead and look at these three problems. With problem number 1, if we have the inverse cosine of square root of 2 over 2, hopefully you got an answer of pi over 4 or 45 degrees. Let's take a look. For inverse cosine of square root of 2 over 2, what do? Well, this time, instead of starting at an angle, we're going to go ahead and find square root of 2 over 2. And because it's cosine, and cosine is our first number in each pair, we're going to go ahead and find where the first number is square root of 2 over 2. So, this asks us where is the first number inside the parentheses equal to square root of 2 over 2. Now, for cosine inverse, we know that it's going to be quadrant 1 or 2 that we look at. So, ignore quadrant 3 and 4. As we take a look at quadrant 1 and 2, we're looking for square root of 2 over 2, which is obviously right there. And so that's going to be our 45 degrees. And we could also write that, of course, as pi over 4. All right, let's go ahead and look at the next problem. For the next problem, because it's inverse sine, we want not our first number, but our second number to be 0. But this time, second number needs to be 0 in quadrants 1 and 4. So we're going to look in quadrants 1 and 4. Where is the second number going to be 0? It's going to be 0 right there. And so that's going to be at 0 degrees or 0 radians. So 0 degrees, 0 radians. All right, let's go ahead and take a look at our last one. For this last one, there's something that I want to review over briefly, which was a subtle thing. Anytime we're in quadrant number 4, which is going to end up being at these possible locations here, we don't want to use 330 and 11 pi over 6, 315 and 7 pi over 4. We don't want to use these values at all. We need to go ahead and use the negative values that are coterminal with this. And so instead of 11 pi over 6, we're going to want to use pi over 6, but it should be negative. Instead of 7 pi over 4, we're going to want to use negative pi over 4. Instead of 5 pi over 3, we're going to want to use negative pi over 3. And instead of 3 pi over 2, we're going to want to use negative pi over 2. If we did them in degrees, it would be negative 30, negative 45, negative 60, negative 90. So negative 30, negative 45 degrees, negative 60 degrees, and negative 90 degrees. Now, let's go ahead and look at our problem. In our problem, we want the arc whose sine is negative 1/2. So we take a look at our second number. And we're only going to look in quadrants 1 and 4. And where's the second number going to be negative 1/2? Well, that's going to happen basically right there. Second number, negative 1/2. What is that going to be? We can't use this. We can't use this. We got to use one of these. And so that would be negative 30 degrees, or that would be negative pi over 6. All right, if you got all those three problems right, that's excellent, because we're just going to today build on these sorts of problems. And what's nice about today's lesson is it's going to be actually pretty easy. Let's go ahead and begin. What we're going to do today is we're going to try to find exact values of more complex inverse trig functions. These are a little bit more complex or complicated, but I don't think you're going to find them to be tough at all. Because if you know those basics, you're going to just basically use what you know about math along with those basics to do these problems. Let's begin. With problem number 1, we want to get the sine of the inverse cosine of square root of 3 over 2. What do the rules of math tell us to do first in something like this? Think about it. Well, in something like this, you probably remember, do what's inside parentheses first. And that's how we're going to try to start each one of these problems. It's going to keep everything simple. So we're going to go ahead and do this part right here first. Ignore the sign. What's the arcus cosinus square root of 3 over 2? Well, doing exactly what we did in the earlier problems there, we're going to end up getting pi over 6. And so this becomes pi over 6. Let's bring down our sign finally. And so here we're going to get sine pi over 6. But what's sine pi over 6? 1/2. And that's it. All right. Why don't you try number 2. Pause the video. Give it a try. Then we'll go through that. Okay, let's take a look at problem number 2. Again, we're going to do what's inside the brackets here first. The inverse cosine of 1/2 is going to end up being pi over 3. So this becomes the tangent of pi over 3. Well, what's the tangent of pi over 3 going to be? Tangent of pi over 3 is going to basically be sine of pi over 3. Let's write this step out here because this will be helpful. Over cosine of pi over 3, like that. But we know that our sine of pi over 3 is going to be square root of 3 over 2. Our cosine of pi over 3 is going to be 1/2. Oops. That's not pretty. And if we multiply by the reciprocal, we're going to get square root of 3. All right. Ladies and gentlemen, let's go ahead and try problem number 3. In fact, I want you to pause it, try number 3, and try number 4 just the same way. Then we're going to go through both. All right, let's go ahead and take a look at problem number 3. Doing what's inside right over here first, the inverse sine of square root of 2 over 2, we're going to end up getting pi over 4. So this right here becomes cosine of pi over 4. What's cosine of pi over 4? Square root of 2 over 2. And that's it. Let's go ahead and take a look at the next problem. The next problem is a little bit unusual because we don't have an inverse trig function in here. But we're going to do it exactly the same way. So here we're going to do what's inside first. What's sine of pi? That's going to be 0. So now we need to do sine inverse of 0. What's sine inverse of 0? That will be 0. All right, ladies and gentlemen, here's what I want to have you do. I want to have you try numbers 5 and 6 now on your own. So take a moment, copy those down, give those a try, then we'll go through those together. Okay, let's take a look at problems 5 and 6. Doing the same thing that we did earlier here. We got the inside right here. What's cosine of negative pi over 2? That would end up being cosine of negative 90, which is 0. And so we're going to do the inverse cosine of 0. And what is the inverse cosine of 0? 1. All right, number 6. Let's go ahead and give number 6 a try. Here we got cosine of 4 pi over 3. And cosine of 4 pi over 3, that will end up being negative 1/2. And so this becomes cosine inverse of negative 1/2. And now we need to think about quadrants 1 and 2. because we haven't done a whole lot of cosine inverses in these sorts of problems. Well, cosine inverse is going to be negative a half at 2 pi over 3. All right, and why don't we go ahead and stop right there. You can go ahead and do the worksheet. Basically, what you need to do is on the back of the previous worksheet, the problems are 21 all the way through 29. Do your best.